Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 4 Additional Mathematics Chapter 8 Vectors HOTS question example 3. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. It is given that vector OP is equals to 4P and vector OQ is equals to KQ, where K is a constant. R is a point on the straight line PQ such that ratio of PR is to RQ equals to 1 is to 3 as shown in the following diagram. So this is the diagram over here. Okay, continue to read the question. For the question part A, they ask us to find vector OR in terms of K, P and Q. Continue to read the question. If the straight line OR is extended to T such that vector RT is equals to 2P plus 5 over 3Q, find the value of K. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. For the question part A, to find the vector OR, so what you can do is you can plus the vector OP with vector PR. But then we have a problem here. We don't know what is the vector PR over here. However, vector PR is in line with the vector PQ. Okay. So the first thing what we need to do is we need to find the vector PQ. So how are we going to do that? So you can use the addition of the vectors. Okay. And then from there, you can able to find the vector PR. Okay. How to find the vector PR? The ratio is already given here, guys, between PR is to RQ. Okay, so what we're going to do now is, so we're going to write down the ratio over here. So the ratio between PR is to RQ is 1 is to 3. So let us write it over here, 1 and 3. Okay, so this is the ratio of the straight line respectively. So now what we're going to do is we're going to relate this with the straight line PQ. So to find the ratio PR in reference to the straight line PQ, so what you're going to do is the ratio 1 you plus with 3 over here. Okay, so 1 plus with 3 you get is 4. So from here what we're going to do is we're going to find the vector PR in reference to the vector PQ. So from here to find the vector PR will be equals to 1 over 4 from the vector PQ. Okay, so I hope you understand, guys. Okay, so 1 plus 3 you get is 4. The 4 is representing the overall length, which is the vector PQ. So to find the PR, what you do? So it will be 1 over 4. Okay, so I hope you understand the concept behind this. Okay, let me box this, guys. Okay, this relationship we're going to use in our upcoming working, but for now let us focus on finding the vector PQ first. Okay, so step 1, find the vector PQ. Okay, so to find vector PQ, so we're going to use the addition of vector where involving the vector of PO plus with OQ. Okay, so from here in the diagram it mentioned that vector OP is 4P. So to find the vector PO, it is just the opposite direction of vector OP. In this case will be negative 4P. Okay, your vector PO will be negative 4P. So from here you get your vector PQ will be equals to negative 4P plus with KQ. Okay, so this is your step 1. Let me underline the vector PQ. Okay, so using this vector PQ, we're going to proceed to find the vector PR over here using this relation. Okay, that will be our step 2, guys. Okay, so proceed with the step 2. Okay, our step 2 will be finding the vector PR. Okay, vector PR. Okay, so to find the vector PR will be equals to 1 over 4 times with the vector PQ. Vector PQ we have already found in the step 1, so you can just substitute the value over here. So in this case is negative 4p plus with KQ. Okay, you times in the 1 over 4. So from here you should get your vector PR is equals to negative p plus with k over 4 q. Okay, so this will be your step 2. Okay, let me underline the vector PR. Okay, so from here we already have vector OP and we have already find vector PR in our step 2, which in this direction. Okay, so now we can proceed to find the vector OR. Okay, that will be our third step, guys. Okay, so from here let us write down the working. So step 3, okay, find the vector OR. Okay, so to calculate vector OR will be equals to vector OP plus with vector PR. Okay, so vector OP plus with vector PR. So let us continue our working. So from here vector OR will be equals to 4p, okay, 4p plus with vector PR. Okay, we can just substitute the value over here. Okay, so in a bracket negative p plus with k over 4 q. Okay, close bracket. So you calculate this. So from here you should get your vector OR is equals to 3p plus with k over 4 q. Okay, so this is your answer for the question part A, where you get the vector OR is equals to 3p plus k over 4q. Okay, let me underline the solution for the question part A. Okay, so let us proceed our discussion for the question part B now. For the question part B, as you look in the diagram over here, there is a new point which is point T. Okay, since in the diagram the point O, point R, point T are within the same straight line, so this condition is known as collinear. Okay, which means that point O, point R, point T are collinear to each other. Okay, so from here what we're going to do is, the first step we're going to find the vector OT. Okay, since in the question part B they already give us that the vector RT is equals to 2p plus 5 over 3q. Vector OR we have already find in the question part A itself. So vector OR you can plus with vector RT. So from here you should get vector OT. So that will be your first step. So once you complete your first step, so the next step what you can do is you can form a relation between vector OR and vector OT. Okay, why is that so? Since the point ORT within the same straight line, or also known as collinear, so you need to form a relation between those two vectors, and you should get a scalar multiple value. And once you get the scalar multiple value, you should do some comparison calculation, and from there you should find the value of k. So this is the overall idea on how we're going to solve for the question part B. Okay, so enough the discussion, let us continue our working now. Okay, let us write down the vector RT given by the question over here. So given that vector RT is equals to 2p plus 5 over 3 q. Okay, like I've mentioned in the discussion, so the first step what we're going to do is we're going to find the vector OT. So let me write down in the working here. Step 1, find vector OT. Okay, so let us continue. So from here, to find the vector OT will be equals to vector OR you plus with vector RT. Okay, so let us continue the calculation. So from here, vector OR we have already found in the question part A, so you can just substitute the value here. So from here, vector OT will be equals to 3p plus k over 4 close bracket plus with vector RT. Vector RT will be 2p plus with 5 over 3 q. Okay, close bracket. Okay, you plus all the respective component. Okay, the component P you plus with the component P, and the component Q you plus with the vector component Q respectively. Okay, so from here you should get the vector OT is equals to 5p, okay, plus with, so k over 4 plus with 5 over 3, you should be getting your answer is 3k plus 20 over 12 q. Okay, so let me underline the vector OT. So the step 1 is clear. So we have already find the vector OT. So from here, what you're going to do is we're going to form a relation between vector OR and vector OT. So let me write down the working here. Okay, since point O, point R, point T are collinear, we can form this relation where vector OR is equals to lambda vector OT. Okay, this lambda is representing a scalar multiple value. You can write any unknown here, guys. Okay, it is up to you. In this case, I'm writing here the lambda symbol. Okay, so let me box this. Okay, continue our working. So from here, vector OR. Okay, let us write down the vector OR. So from here, 3p plus with k over 4 q close bracket is equals to lambda times with vector OT. Okay, substitute the value over here. So from here, 5p plus with 3k plus with 20. Okay, let me underline the fraction. Okay, let me erase this as well. Okay, over 12 over 12. Okay, close bracket q. Can close bracket. Okay, so from here, the lambda you times in, you should get, okay, the left hand side still remains the same. So 3p plus k over 4q is equals to 5 lambda p plus with 3 lambda k plus with 20 lambda over 12 close bracket q. Okay, let me underline the fraction. So now you need to find the lambda value. Okay, you can compare either with component P or with component Q. Okay, in this case I'll recommend you to compare with component P because it is very direct over here, guys. Okay, so compare with component P. So from here 5 lambda is equals to 3. So from here to find your lambda, what you do, 3 you divide with 5. So from here you get the lambda is 3 over 5. Okay, so this is your scalar multiple value. Okay, but then this is not the final answer. You still need to find the value of k. Okay, so to find the value of k, what you need to do, you need to substitute this lambda value back into the equation here. So from here, let us continue our calculation. When lambda equals to 3 over 5, okay, so from here, the left hand side still remain the same. So let me copy paste this. Okay, but then for the right hand side, okay, there will be some new calculation. So please follow up with me. So from here 5 times with 3 over 5 close bracket, okay, times with component P plus with 3 times with, okay, we decided to write the k over here, okay, times with the lambda value 3 over 5 plus with 20 times with 3 over 5, okay, and you divide with 12. Okay, divide with 12. This way, guys. Okay, component Q. So from here you continue the calculation of the fraction. So the left hand side still remains the same. Okay, so you copy paste this. So this one, the 5 you cancel, you get 1. You cancel the denominator, you get 1. So your P will be 3P. Okay, so from here you get 3P, okay, and then plus with, okay, so this calculation will be slightly tedious, so please follow up with me. Okay, you solve this, you get 9k over 5, okay, and then you times this, you get plus with 60 over 5. Okay, so you combine them together, you get 9k plus with 60 over 5. Okay, but then remember, guys, you still need to divide with the 12 over here. Okay, okay, since you are dividing with 12, so this divide with 12 you change with fraction here, which will be times 1 over 12. So 9k plus 60 over 5 you times with 1 over 12. So from here you should get 9k plus 60 over 60. Okay, so this is the working, guys, the working inside the fraction. Okay, so please wait. So 9k plus 60 over 60 component Q. So this is your working. So now what we're going to do is the step 3, we're going to proceed to find the value of k. So let me write down the working now. So step 3, find the value of k. So from here, P and P we cannot compare anymore because the value are the same, but you can compare in terms of component Q. So from here, K over 4 you can equate with 9K plus 60 over 60. So from here, compare the component Q. So from here, K over 4 will be equals to 9K plus with 60 over 60. Let me underline the fraction. Okay, for the next step, what you do, you cross multiply. So from here you get 60K, 60K is equals to 36K plus with 240. So this 36K, you move it to the left hand side. So 60 minus with 36K will be 24K. So 24K will be equals to 240. So to find K, what you do, 240 you divide with 24. So from here you should get your K value is equals to 10. So this is your answer for the question part B, guys. Okay, let me outline the solution. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Any comments, question or feedback, feel free to put down in the comment section. Thank you everyone for your support, and I'll see you in the next video.